Let's look at the next LOS. We're talking about calculate and interpret measuring of central tendency. Now, this is where you can officially state that we are getting into stats. Okay, so you will have to understand these concepts at a high level of depth, because all the other readings after reading 2 are going to be intense on statistics. So if you don't get your central tendency concepts well, so I mean from here onwards, it's entirely, you can say, a foundation for statistics, right? So you need to get this straight from logical level. Okay, not just knowing that you know how to calculate. That's not going to work. You need to understand the inference. So, as I said, it's very important that we keep this second part of central tendency as a separate session, because it is going to be a little more intense, and since it's a foundation. So let's get straight to it again. So whenever we say central tendency, we automatically get this thing in our mind, okay, it's going to get complex, right? But let's try to understand it in a very simple language. Most of the times, we are always interested in some middle value. We are not really interested in maximum value or minimum value, maximum package, lower package. We are interested in what is the average of things, right? So for example, we tend to ask questions like, what is the average house price, right? What is the average score in an exam? What is the average salary? What is the average expenses? Why are we so interested in averages? Is because if you were to actually plot all the data points, you will see that the maximum amount of occurrences tend to happen somewhere in middle, right? So it's pretty obvious that if you were, let's say, finding an investment option, you would be interested in what usually happens, right? Right? And not so much interested. So you are really interested in what usually happens than asking questions like, what is a one time event, right? You're not really interested here, because you are interested here if you're talking in terms of risk, but from a returns angles, you're talking about what usually happens, right? So that's where this concept becomes very, very important, because from here itself, the concept of risk will also come. Okay, so let's look at the fundamentals of central tendency. If in case your mind image is blocking the topic out here, it's another y. All that is written here is a y, so don't worry. Okay, so there are three ways in which you could find what usually happens. It's not always a mean. Okay, so either you could calculate it numerically, stating that let's focus on the value itself. So if I say 5%, 6%, and 7%, then one way to find out what usually happens is to just 5 plus 6 plus 7 divided by 3. But that's only the numerical way. Okay, the other way is to find how many times it happens, which value occurs, just like histogram that we covered, right? How many times does it happen, right? That could also give you what usually happens. And finally, the third is stating that, I don't care how many times it happens or what is the numerical value. Let's just try to order the data in an ascending order, right? And just try to find out the middle location. So these are the three approach to central tendency. Okay, so let's look at this example out here. So if you see score in English 12, 15, 20, 20, 40, 45, right? Now, if I were to numerically calculate this, I could just add up the values and divide by the number of observations. Straightforward, you will get the average as 25.33. But if you were to find out the location instead, what you would do is, okay, you say that, okay, this is the first observation, and you have to obviously order the data in ascending order, right? So this is already done. So second, third, this fourth, fifth, and this is the sixth observation arranged in an ascending order. The main thing is it has to be ordered in either an ascending or a descending order. Okay. Now, if it has been arranged in this way, you would see one feature of this number of observation is that there are 6 observation, which means it's even number of observation, right? So if I were to say to find out the middle location just by visually, let's see if it's even possible. Okay, so look at here. So this is 2 observations to the left or the top and 2 observation to the bottom. So it's not really possible to find one single location if it's even. So there are 2 locations out here for the middle location or nothing but median. Okay, so there are 2 locations. Again, out here what you would do is, if in case you are in this fix where you have 2 locations, a simple method is to just take now the numerical average of these 2. So see how even finding the middle location finally gets the numerical calculation itself. So now what would you do? You would just do 20 plus 20 divided by 2. So this is my middle location itself, right? So, and mode is trying to find out which is the highest repeating value. So in this case, since we just have one value which repeats twice, so our mode is 20. It is not necessary that the data has to have only one mode. It can have, this is a unimodal scenario and there's only one mode, but there can be data points which have bimodal or trimodal or many models, right? And practically speaking, mode becomes finding a one particular value in case of mode, in case of financial data, is very difficult because the data is continuous, right? So in case of continuous data like stock market data, you tend to use frequencies in a range, just like we talked about in the frequency distribution, rather than actually using a unimodal concept. Okay, so that's the fundamental of central tendency first. Okay, but as I said, why are we interested in the center? If you understand this, then you'll also understand risk. Okay, so now I'm taking up an example of finance. Okay, now and at this stage we really want to look at a spreadsheet, because if you really want to get the concepts clear, we should look at a spreadsheet, we should look at data. Okay, so without wasting much time, let's just switch to a spreadsheet. Okay, so we are in the spreadsheet now, and as I said, why are we interested in the center? Because we want to know what kind of returns are we usually going to, and what kind of uncomfortableness are we going to really feel when we invest in this mutual fund of Franklin, right? So and we have daily returns, so maybe we want to answer that, how uncomfortable are we going to feel on a daily basis, right? How much fluctuation is going to be. So then we use the average, the simple average, the numerical average. And if I want to find out median in this case, of course, in Excel, it's very easy. You can just use the median function. You don't even have to order the data, because it will find it by cell. So you can see that, okay, my average in terms of a numerical average is about 0.58. And my median is about 1.02. Okay. So that means on a daily basis, I'm going to be okay. But again, you want to find, does this really answer your question on whether, you're going to be feeling uncomfortable or not? Well, it depends what you want to derive out of it. So maybe you want to find out, if this is average, then how much does the data really fluctuate from the average? Are you getting what I'm saying? I'm trying to answer the question that if this is usual, this is the middle point, this is the central tendency of the data point, then usually what is the fluctuation from the average, right? That is nothing but deviation, right? Now we'll get back to the deviation, but I want to quickly show you what it looks like in terms of a chart also, right? So if I were to plot this, okay, so I'm just going to quickly plot this. Oops. Yeah. So you can see that this is how, okay, now this chart is not very useful. Let me just change the chart type. Let's see if we can get some appropriate charts. In fact, actually this chart is not going to make sense itself. So we need to find out, we need to create a range. So let's create the same histogram. Okay, so that will make more sense. So I'm going to find out the maximum fluctuation out here. Okay, and you really don't have to do this. You can just observe and just make sense of it. and this is the minimum fluctuation. So how much has it gone down in a one particular day? Okay, so that's minus 26, right? Now let's create a range. Okay, so let's start from the lowest point, and then let's say we create a difference of 5%. So that's the bin range that we're talking about from the previous section of visualization data that we were doing, right? And now let's just extend it till about 19%, so that's okay. And now let's count how many times it's happening. Okay, so remember our average is about 0.58, so it should be somewhere around between 0.7 and 4.3. So let's see how it actually looks. So let's go to data and create a small histogram. Okay, so that's my input range. Let's see, let's select our bin range and let's create a output range. There you go. Now if you see the chart, it will make sense. Okay, so let's create a chart. There you go. So now if you see this, right, you will see that 0.67, which is our average, right, 0.58. We are interested in understanding how much does this on a usual basis fluctuate from our mean. So if can I actually use my pen tablet here? Let's see. Yeah, I think I can. So let me see if I can draw something out here. Okay, so let's say the value of 0.58 is somewhere around here. Okay, so let's say this is 0.58%. Now you can see that on a usual basis there is fluctuation, right? You can see this is the fluctuation one. This is also fluctuation. This is also fluctuation, right? Even on the right hand side, this is also fluctuation. This is also fluctuation. So we want to also find out what is the average fluctuation from the mean. That is why we are interested in the central tendency at the first place, not just to find out what is the average returns, because average returns will only give you some limited information, but how much does it fluctuate from the mean will give you the fact that how comfortable or uncomfortable are you going to feel with this investment product. So that's the first step. Okay, now let's move forward. Okay, so now we are back to our boring PPT and we look at arithmetic mean properties. Okay, now since you are using the numeric method, numeric method, because you're actually performing some numerical calculations and then you're trying to find out the central location. So you need to understand what is the effect, right? Or probably you can say what are the weaknesses. Okay, so if you see this data set A and this data set B, okay, and you can see that most of the data is same. I mean, everything is same actually, okay, except this data point and this data point, in which you will see that the data set B is erratic sometimes. Okay, so these are, you can call these as outliers. Okay, now if you look at arithmetic mean, the arithmetic mean comes up to be 32 in case of data set A. But look at the fluctuation when some outlier even happens, right? Huge. The reason why this happens is because you have to understand that you are doing A plus B plus C divided by the number of observation. So your calculation for both these are not really changing, isn't it? Because you're still dividing by the number of observation as 7. So in both the cases, your denominator is still 7. But your numerator tends to change a lot by these outliers, right? Because you can see out here that 45 and 100, so there's a difference of 55 out here, and there's a difference of 25. So your numerator is changing big time, but your denominator is same. Hence, the arithmetic mean, gets affected big time, right? But look at median has no effect of outliers. So that's something to understand. That when you have outlier data, you also need to ask yourself, is the outlier data reliable. So as long as the data is reliable, no problem. For example, you're looking at stock market data, right? Let's look at the spreadsheet quickly, okay, so that you get this point through. Look at this spreadsheet data in which what is the outlier? The outlier is this, and the outlier is this. Or maybe you could also call this as outlier, because usually you don't find minus 25 and 25 maximum happening in a single day, right? And if you look at the frequency, you'll understand. See, minus 26 during this time period has just happened once, and 14% and 9% also happens limited amount of times. So since the stock market data is reliable, maybe I don't really need to worry about changing the data or trying to manipulate the data. I'll take the same data, right? But if the data is not reliable, let's say in terms of if you're looking at a startup, a startup with its performance, the outlier event, let's say we're talking about a startup company and we are analyzing their financial data of 3 years, right? Maybe the first year, since they were starting up with as a small business, maybe your performance, your revenue grew by 35%. But that's not probably sustainable, because you started from nothing. Let's say at year 0, your revenue was only, let's say 1 crore, and from 1 crore you jump to 10 crores. So it appears as if the revenue growth is high. So that outlier is not reliable, right? But in case of stock market data, there's nothing of that sort's effect happening in the stock market data. So you can really, do nothing about it, right? So that's what the answer is also here. How do you handle these outliers, right? In case of unreliable data, you can delete the data, right? Which if you delete and then calculate the mean is also called the trimmed mean. So if I remove these outliers absolutely, then will be a trimmed mean. Usually done, as an example, it is done in sports competition when the performance can be just a one-time event. When you replace this with some values, okay, so maybe what you do is you calculate some usual values which might happen. So maybe you calculate the average itself, right? Let's say the arithmetic mean itself, you add 32, then that would be called as a Winsorized mean, okay? So just a terminology, but all you're trying to do is either delete or replace or do nothing. But doing nothing, the data has to be reliable. Look at the median properties. So median is straightforward. It's just trying to find out the location. And this median concept is finally also related to concept of percentile, quartile, etc. Okay, because you're just trying to break down the data. That's all that you're doing. Now, the only thing to learn in case of median is just to know what to do in case of odd and what to do in case of even. Okay, if it's odd, it's very simple because you can clearly split the location to two sides and then just find out the middle point. If in case it's even, that's where you get two locations. But it's very simple in case of two locations. All you need to do is take a mean of these two values. Okay, so that's all that you really need to do, right? So if you can see out here, obviously some formulas are given, but if you look at logically, it makes sense, right? They take the mean of two values and that would be your median. Okay, so that's median. The mode, as I said, I've already covered this. A data can be unimodal, it can be two modes. For example, there might be frequencies in which 2% might be repeating 5 times and 3% also might be repeating 5 times. So then you have two modes, right? Okay, weighted mean. Now this concept again in the future readings will also get used in probability. So nothing much to really worry about here, but all you're trying to say is this, that instead of just calculating 9 plus 15 plus 12, which is what you usually do in a arithmetic mean, what if that 9, 15 and 12 is basis some proportion in the background. So let's say you have a portfolio in which you have 15% allocated for gold and 60% allocated towards equity and 25% allocated towards bonds. Now it won't make sense if you just do 9 plus 15 plus 12, because that is wrong information. So what you do is you just multiply these. okay, and then you get some uh, proportionally weighted returns out here, and then you just add it up. Straightforward. Probability, okay, just trying to give you a heads up on probability also. If in case you replace, since this you're talking about empirical data, right, because this is historical, usually the returns have already happened, and hence you are multiplying the weightage. But instead of empirical, if you were looking at forward or future, then if you just replace this with probability, let's say the probability of gold generating 9% return is, let's say, 7%. So then instead of the proportion of the weightage in the portfolio, you would just replace it with probability. Just giving you a heads up. Don't worry, that will get covered. I'm just giving you a sneak peek. Okay. Geometric mean. Again, people try to memorize this formula. I don't know why. If you just try to look at the concept well, it's nothing but the future value formula. Okay. Let me prove it to you. So if you see, on year 0, let's consider $10 invested, okay, or even $1, that's okay, and you generated 4%, so your value obviously becomes 1 into 1 plus 4%, which is nothing but 1.04. That is how the calculation happened here, okay. And now look at what is happening after that, okay. So after that, 1.04 is again generating 3%, so you're getting 0.712, right? Simple future value calculation. Now, if you were to calculate the rate of return during this period, what would you do? You would take 1.12476 divided by the present value, which is 1, and you would do the rate function, if you remember, right? Future value divided by present value raised to 1 divided by n minus 1. If you don't remember this, go to the reading and revise this, okay. But that's how you would calculate the rate, right? And exactly the same thing is your geometric mean. That's it. All you're trying to find out is the rate, right? So don't get confused when somebody is saying geometric mean. Geometric mean nothing but the rate function itself, right? And if you want to simplify this, see, I've simplified it out here also. If you just keep 1 as constant, right, because you invested 1 only once, and you are compounding all the rates, 1 plus 4, 1 plus 3, 1 plus 5, right, 1 plus 4, 1 plus 3, 1 plus 5, and all you get is 1.124, and your future value becomes 1.124. Now just use the rate function to find out 1.124 divided by 1 raised to 1 divided by 3 minus 1, and you have a geometric mean. That's it, right? So since it's a rate function, you have to understand that geometric mean makes more sense when you're looking at compounded numbers. Harmonic mean. Okay, remember the problem of outliers with arithmetic mean, in which we said that the outlier have a lot of effect on our mean. So if you know that your data has a lot of outliers, significant, then in order to remove the effect of the outlier, what would you do? You would take an inverse of their proportion. It's funny, right? You are saying that in the same example of this data that we were looking out for, right? This one, right? So now if you say that this data point has a lot of effect on our arithmetic mean, so you know what, let's inverse the proportion of such outliers, and that would be harmonic mean. Okay, so let's look at this example itself. So if you see P ratio, nifty, 25, 35, 40, 20, right? And let's say that we are saying that these two values have the highest outlier effect on our mean. So if we just take the opposite of this, right, if we take the inverse of these values, right, you would get some proportion. So you're getting, the higher the outlier event, the lower the proportion is what it is getting, right? And you would get the sum of all this would become 14%, right? So now what you do is just take the number of observation, which is 1, 2, 3, 4, right, divided by the sum of inverse, and that should give you the harmonic mean. But you need to understand, more than the calculation, you need to understand where it is getting used when you have significant outliers. Okay. Now let's look at alternative definitions of mean to address investment problem. Okay, so again, first I've summarized this data. Okay, so the additive principle is arithmetic mean, and if it includes outliers, but the data is reliable. Okay, if you add proportion, then you are talking about weighted mean. If you have significant outliers, extreme outliers, then you just take the inverse of their weights, and it's called as harmonic mean. This is nothing but the rate function. Okay, frequency we discussed, I think, many times. In case of continuous data, the histogram itself will tell you the mode. If you look at the location, till now we know that the median is used. But if you have even number of data points, then you need to again use the additive principle to find out the central location of the data. All right. So the green signifies the variation, the blue signifies the principle, and the brown shows the use. Okay, now we are into variations of concepts of finding the location, which we already discussed in terms of median. Right now, we are looking at other ways of looking at the location of the data. Simply put, you need to understand that if there are 2 parts, then you're talking about median, 4 parts quartiles, 5 parts quantiles, 10 parts deciles, and 100 parts percentiles. Simple. So if you were to have a data set and you want to see it in a percentile method, then you need to divide it by 100. Meaning you get to divide that in 100 different parts, and then you can talk about each 100 part. You might say that 99 percentile location is this, the 1 percentile location is this, right? If you were talking about quartiles, you might say that 3rd quartile, this is the value, 4th quartile, this is the value, right? So that's how it is. But it doesn't make sense unless we look at the data. Okay, so I've taken the CFA curriculum data set itself, and let's try to understand this, because I think this is a perfect example. Okay, now please understand in the background, this is basically again stock market data only. Okay, so they are the sample trading days. Okay, now what they've done is they've divided the data into 100 samples, or you can say sections. Okay, doesn't mean that we just have 100 trading days. 100 data points. It means that the data has been split up for 100 trading days, and the bin range is 5. You can see the difference is 5, right? Now if you were to look at this data in terms of percentiles, then basically you have 100 parts of the data, right? So if you look at the 95th percentile section, you will see this is my 95th percentile section, right? This is my 90th percentile, right? So it's a range, right? So the lower bound is 0.738 and the higher bound is 0.991, right? So that's what is the concept of a percentile. Now let's move into quantiles. Now if we're to say that the data has to be divided into 5 parts, then what would it be, right? So if you look at in terms of 5 parts, you need to understand quantiles has 5 parts, right? If you are saying 5 parts and you have, let's say, 100 bins or sections of the data, that means you basically have 20 areas to look at, right? Or 20 sections, right? Now the first quantile, that means if you have about 100 trading days, then the first quantile has to be the lowest 20 observations, right? So you can see out here I've marked it that the lowest 20 observations would be between negative 0.432 or lower, right? So let's look at negative 0.432 and lower. So this would become my lowest quantile, right? First quantile, right? And second quantile would be from 0.432 to another 5 that is still here. So this is my second quantile. Then this is my, so 1, 2, 3, 4, 5. So this is still here is my third. Am I doing it correctly? 1, 2, 3, 4. Okay. I've taken one extra here. 1, 2, 3, 4. Yeah. So till here would be 3. Then from here to 1, 2, 3, 4 would be fourth quantile. and this is my fifth quantile. Looks complicated, but it's not. Okay. If you look at it in terms of quartile, so you're saying that you've got 20 ranges out here, right? You've got 20 bins. So if you were to divide it by, let's say, 4 quartiles, right? So that means 5 bins, right? So let's start from here. Okay, so we want 5. So this will be my first. From here, this is my first quartile. Then from here, 1, 2, 3, 4, 5 till here is my second. 1, 2, 3, 4, 5. This is my third. And finally, this is my fourth quartile. Straightforward. Just need to understand how to divide the data. Right? Now, the beautiful part is that if you were to, I've actually, again, let me show this in a spreadsheet that would be more useful, right? So let's switch to how to visualize this. So this is the median that you see. The mean is between 0.2 and 1.46. Okay, this is the minimum point, this is the maximum point. Okay, and this is your quartiles, the interquartile range. So this is the highest, this is the lowest, this is the mean, this is where the mean is, this midpoint is the median, and this is your quartile range, the largest and the lowest. So the highest boundary of the third quartile and the lowest value of the first quartile. Okay, that's the difference. That's what the interquartile range means. Okay, this is the lowest boundary of quarter 2. That's basically nothing but the quartile range, right? So this is how you basically visualize quartiles. Okay, you need to just know what this means. Okay, you just need to interpret. So if a question comes up, they are showing you a box and whisker plot, you need to identify what means what. Let's look at an example CFA curriculum question. As we see out here, it's best to practice questions to actually know whether you know things or not, right? So you want to pause the video and probably just give it your own shot. That would be preferred. Okay, so solving that example, the CFA curriculum example, I thought that it's better that we actually look at a clean board where you can actually solve this. Okay, so the first, you would say the step would be obviously to make sure that you actually arrange the data in ascending order. So the first step that we have done is out here is to arrange it in an ascending order. So now this might take you a bit of a time, but expect that in the exam you won't really get questions which are so time consuming. Rather it's going to be very fast. So but for the purpose of the calculation is what we are trying to understand this, right? So first we did it in ascending order, and let's understand how the data is first structured. The first structure is that we know that we want to arrange the data in quantiles. Now we understand that quantiles means 5 parts, right? So if we know that the data has to be divided into 5 parts, so let me take some other color out here, right? So this would be my first part, this would be my second quantile, third, fourth, and fifth, right? So this is my first, second, third, fourth, and fifth quantile, right? Now once I have the quantiles, we need to understand that the calculation is much more easy using the percentile, right? So if we are interested in the fourth quantile, which means we are looking at this point out here, right? And you can clearly see that in terms of the number of observations, this is the 8th observation. Or you could also say that 80% of the observations lie below this, right? So we could also say that if 80% of the observations lie below and percentile means 100 parts, right? So percentile means 100 parts, right? So we could also say that we are interested in the 80th percentile value, right? Now I'm not referring to any formulas, I'm just trying to use logic out here, right? Now if we are interested in the location of the 80th percentile, just like we were interested in median location, and considering that this is a sample, we would, and also the fact that we have even numbers out here, so we would take whatever the number of observation we have, which is 10 plus 1, okay, the reason is because we're dealing with a sample, right? So 10 plus 1 into, okay, let's look at the number of observations. We have got about 10 observation, right? Sorry, so we are looking at 10 plus 1 observation, and we are interested in the 80th location, which is nothing but saying that we are interested in the 80% value, right? So because this is 80th%, right? So this should give us 8.8th position. Now, if you look at the data point, there is no 8.8th position, right? Because we have the 8th position. So now if you want to find the 8.8th position, all you need to see is, now let me change the color again so that you don't get confused out here. I'm going to take a smaller value and yellow. Okay. So 80th position, 8.8 position is somewhere between 8th and 9th, right? Now, this is what is formally called as linear interpolation, but all that means is just find out the difference between these two values. So if you see that the 9th value is 27.37%, and the 8th position value is 20.65%. So if you find out the difference between these two values, you would get 0.52 and then 7.52%, right? So we are going to linearly say that, okay, 88% of this difference is exactly my value, right? 0.616%, that's the difference. But my 8th position is 20.65, right? So all I do is take this value out here, say that this is my 8th position, 20.65%, plus by linear interpolation, what we just did is 6.0616%, which gives us the option which is given in the, which gives us the option of 20.65.